this question on circuits, none of the parts of the question are particularly difficult, but there are a few things that you need to do to get the answer. Much of it requires the sort of things you will have known from GCSE level. So if I just quickly sketch out the circuit, we've got an internal resistance of 10 ohms here. That doesn't really matter if it's an internal resistance for the question. We can just treat it, there's no difference with it being an external resistance or an internal resistance. So we're given that resistance value. We're given that there is an LED in the circuit, and again, the fact it's an LED doesn't matter either. And then we've got a resistance R there, and we're asked for the resistance R of that resistor. So there's a few different ways of approaching it. So I would probably look at, we know that the potential dropped across this, the LED is 1.8 volts. So I know that value. So I can work out the resistance of the LED. So the resistance of the LED, I'll call RL, is the potential difference dropped across it over the current. The potential difference dropped across it I'm given in the question is 1.8. The current is 20 milliamps, so be careful, it's milliamps. And if I put that in my calculator, so 1.8 divided by 20 times 10 to the negative 3 to get the milliamps, and I get that it's 90 ohms. So I now know that the resistance of this is 90 ohms, the resistance of this is 10 ohms, and this value will add to that because they're all in series to give me the total resistance of the circuit. I can find the total resistance of the circuit, so I can find RT, I'll call it, is the total potential difference supplied to the circuit, to the EMF of the supply, which is 5. The current is the same all the way around, so that's going to be 20 milliamps again. So 5 over 20 times 10 to the negative 3 gives me the total resistance of the circuit. So 5 divided by 20 times 10 to the negative 3 gives me 250 ohms. So the total resistance is 250 ohms. So that 250 ohms must equal the 10 plus the 90 plus the missing value. And you can see that the missing value, therefore, is 150 ohms. There are other ways to do that, but you sort of end up at the same point. There are ways you could do it. You could work out what the missing voltage is, the missing potential is across each. But I think that way is fairly straightforward.